All right, continuing law of cosines. Last time we were together, we spoke about when I have an angle with two sides, none of them corresponding, I can use the law of cosines to find an answer, but it's all based off of this angle and using the biggest one. Now, what happens though if you only have three sides to work with? Well, it changes things a little. I still could go ahead and use this formula, but there's going to be a whole lot of algebra involved with it, which can cause us more issues. So there's a simpler way to do it, and that's to look at this in its fractional form. So this is good when we have one angle and two sides to work with. But what happens if I have three sides? Well, we're going to take a peek at that right now. I'm basically going to have done the algebra for you already on this. So this, for instance, if I was attempting to find angle A, and I would be if I have all the sides already, I'm going to add up the squares of the other two sides and subtract the square of my third, and then I'm going to divide that by 2 times the product of the other two. All the same pieces that I had in this equation are here. All I've basically done is solve for cosine of A. So this, you'll notice, was the same. I minus the A squared over divided by the 2BC. And that's going to be true for every version of this. So like if I'm looking for B, I'm going to take the squares of the other two sides, not named B, and subtract by the B squared side, and that would be over 2 times A times C. So we don't see a whole lot of the variable that we're actually looking for. It's mainly the other two that we're going to write in. And then that last one, because of course we have to have one for C. I'll keep this on the screen here. Uses A and B prevalently. And gets me set. And like I said, you can use our original equations to find angles as well, but this just sets it up where it's one nice fraction, you're done, you go on with your life. So we're going to take a look at a couple of these and a couple of application problems to try and help out in getting this situated. So let's say here we look at A. Now, here's the key with these though. Okay, when we're dealing with law of cosines, we want to start with the biggest side. You're like, well, why? Because if you don't, you're going to get some things messed up. Your angle measures are going to be off by a degree or two sometimes. Not every time, because I know somebody will test me while we're doing this, and you'll say, hey, I got the same answer you did. But if you don't use them in the proper order, there will be some problems where you get messed up. So if you want to gamble, you can, but I'm just telling you, it could bite you in the butt. So here, my biggest side is A. So I'm going to look for angle A because of that. So I get here and I go, okay, I'm going to be looking for the cosine of A. So I'm going to use this form right here. And again, to put some of you at ease, when we get to the quiz, your forms will either be on the quiz physically, or I'll give you like a cheat sheet that you'll be able to use that has them on there. So you're not going to have this drilled into your memory completely, but you're probably going to want some practice to know which one you should use. So B squared plus C squared minus A squared over 2 times B times C. And the parentheses are critical. You forget them, this is not going to work out well at all. And if you have not checked already, again, check your mode. Make sure you're in degree, because I still have some shady characters that are deciding they're going to put them into radians just for fun. Shouldn't be at this time of the day, but you never know. And basically from here, I'm going to type in all of my values for my numerator and then divide by the values in my denominator. Now, I did have somebody earlier, I asked, well, could I just type in this first part and hit enter and then just hit divide by and hit this part? Sure, if you're worried about, having an issue somewhere. Now remember though, when we're looking for an angle, and I'll just jot down the decimal form in case I press the wrong button here or something. I'm looking for second and that function to get the angle. And then second and negative on our calculators to give me that former answer. Or I can just type in like the first three values. That'd be okay too. So angle A is 82.1 degrees because we were asked to round to the nearest tenth. So that's what I'm going to do. But here's what that does for me now. Now I have a corresponding angle and side. So I can use the law of sines to finish the rest of this. Because I go, okay, so I've got the sine of 82.1 over 22, corresponding side and angle. Well, how do I decide which side to do next? There will be arguments that often enough it doesn't make a difference that I'll just do whatever one I want. It's fine. But if you want to make sure you're not that person that ends up off slightly, it's in your best interest to use the smallest remaining side on sines. Okay? So cosine we go biggest, sine we go smallest, just to be on the safe side. So I look and I'm like, okay, well, what was that going to be this time? Well, the smallest side is going to be side C. So I'm going to use side C, and I'm going to be locating angle C. And I put the -1 just to remind me that I'm going to be using second because it's an angle that I'm looking for. So I do my work. I go, okay, there's the diagonal. It doesn't have C. So 14 times the sine of 82.1. And I divide by the diagonal that has my sine value. And I let the calculator do the rest. So 14 times the sine of 82.1 by 22. Again, it's an angle. Again, it's sine this time. Be careful. If you use cosine again, you're not going to get the right answer this time. All these little details to play with. So C is going to be 39.1. And then I get to do the easy part. The last angle, angle B, is just 180 minus the sum of the other two angles. So B is 58.8. And again, sometimes you'll be asked to go to the nearest whole degree, sometimes it'll be the nearest tenth. You just want to read your directions over. But that's what I'm on the lookout for as far as these go. And also, like I said, some of you will find occasionally, if there's only a certain angle you're looking for, you can get away with trying to shortcut it, but I wouldn't want to be the person that gets burned the time that, well, that doesn't work. Okay? Just to let you see that it's not going to be A every time, we're going to go down to number 4 because I want you to get some experience with the different fractions that we're dealing with for forms. So we're going to move over here. And I look and I say, okay, this time B is the biggest side. So that's where I'm going to start. So I'm going to use my cosine B fraction. So since I'm looking for B, again, I square the other two sides, so 19 and 13, minus the square of my b over 2 times a times c. And I let the calculator do its thing. Again, parentheses, critical. Forget parentheses, forget about getting the right answer. Unless you're going to do a lot of individual pieces. And again, I'm doing cosine with this one. So second cosine, I'm looking for an angle. So it looks like B is going to be 79.6. Then I look ahead and I'm like, okay, well, I'm really wanting to find A. And the temptation is there. I'm like, well, I'll just do A now. Well, wait a minute. Oh, yeah, when I go to sines, I'm supposed to use the smallest side to make sure I don't be that person that messes this up. So I get here and I go, okay. Got my corresponding side and angle. So I'm going to do that next. So sine B over B. I have side C. I'm going to find angle C. And again, I'm on sine now, law of sines. So I look and I go, okay. There's my diagonal. It doesn't have C in it. There's my diagonal. It does. That's what I'm dividing by. So I pull that up, and I'm like, all right, 13 sine 0.6 divided by 21. Again, that's my decimal form. I need the angle, so I do the inverse of sine, second sine, plug in that decimal. C is going to be 37.5. And then again, to get my A, I'm just going to take 180 minus the sum of the two angles that I've already found. Find out A is 62.9. That's what I'm trying to do with these. Now, like I said, if you want to try and be sneaky, and if it says A, you try to just use cosine of A and do it, and you get lucky, and it ends up being the right number, hey, it is what it is. But if you want to be sure that you're getting it right, follow the rules. Biggest number to start, even if that's not the angle you want, smallest side when you're doing the law of sines, and work it from there. So I want to go to applications now because we get to do the same thing with them, so it's not like we're not getting more practice. So okay, two radar stations 2.4 miles apart are tracking an airplane. The straight line distance between A and the plane is 7.4. Well, it's nice they're labeling everything for us. The straight line distance between B and the plane is 6.9. What is the angle of elevation from A to the plane? What's this angle over here? Now again, I'm a fan of labeling stuff. Labeling my angles, labeling my sides, so I know what I have and what I'm looking for. Okay, I'm looking for angle A. Okay. Now, am I going to be brave enough to find angle A right away? No, because which side is biggest? B is. If we're going to make sure we do it correctly, that's where I want to start. So I sit here and I go, okay, step one, I'm going to figure out what angle B is here because that's my biggest side. So I go, okay, So the cosine of b is going to be my other two sides squares. And if you have to, you can flip back and forth. Minus, ooh, I almost messed that up, my b squared. Okay. So for those of you wondering, now wait a minute, what's he doing here again? I'm using this, so a squared plus c squared minus b squared, and then I'm going to do 2 times a times c down below. So 2 times a times c. And that's why I like to label all this stuff, because that way I don't have to worry about messing this up. And as long as I get my parentheses in there, life is not going to be bad on me. I get there, I'm like, okay, second cosine, can I do that with a net? Oops, back up, Harty. So I get there, and I'm like, okay, so B is 92.4 degrees. Okay, so that is 92.4. Well, whoop-de-dee, Harty, I'm not looking for B, so what good was that? Well, actually it did us a lot of good, because now I have a corresponding angle and side. So I can use law of sines for that. The other nice thing at this point is, when I do sines, I'm looking for the smallest side that's left. Hallelujah. I'm looking there and I'm like, oh, dang. You mean now I'm trying to find angle C? Yeah, but we know how easy the other one's going to be. Because again, I'm not going to be that person. I'm not. So I go, okay, C is not going to take me long. Because when I start to look and I'm wanting to complain and I'm wanting to go, oh my gosh, this takes too long. And then I actually look at the time it takes once I punch it in the calculator. I'm like, yeah, it's a minute or two when we're talking about a few problems is not going to be the end of civilization. And we just divide by whatever's with my sign in that diagonal. And we just do our second sign and plug the decimal in. So C is 18.9. And yes, we now have finally made it to a point that we can get the answer we've been looking for. To get A, it's 180 minus the other two. So again, just kind of work through those steps. It'll make life simpler on you as we finish some of these up. So one more here, and then I want to take a look at a few on the packet, because again, I want to reinforce that these aren't bad. It's just plugging numbers into formulas once you get the hang of it here a little bit. So all right, last one on the notes. So camping at Shady Pines Campground, campsites A and B are 80 meters apart. Oh, okay. I don't even know which way to go, so I don't know. It doesn't matter. A and B are 80 meters apart. The camp office is 95 meters from campsite A. Okay. This is the office, but I'm still going to call it C. And 115 meters from campsite B. Ooh, I got all the sides. So, when the ranger is standing at the office, what is the angle of separation between A and B? In other words, how big is that angle? So you're like, okay, so I want to find angle C. That's my goal. Now again, might I be able to do it directly? We'll see. So I start looking. Okay, I got three sides, so I know I'm using law of cosines. Which angle am I going to be finding first? A, because there's my biggest side. So I go, okay, now this time all sides. All right, so I'm looking for A. So I go back, I look if I need to, and I'm like, all right, so it's B squared and C squared. The order doesn't matter, so if you did, you know, here's B, here's A, you're like, why'd you switch them? Doesn't matter. Minus A squared. And then 2 times my 2 sides not named A. And as you start to do them, you kind of get into a rhythm, and you're like, you know what? I might not even need to be looking at the cheat sheet, because if I do a few of these, I'm going to have seen all these numbers so many times that it's going to be second knowledge to me here. And again, it's cosine the first time, so don't get those flipped, because that will definitely get you a different answer. Okay, so A would be 81.7. Again, the advantage that gives me, angle and side now, so I don't have to do cosines anymore. You never will have to do cosines more than once in a problem. If you do, something went haywire. So then I look, I'm like, okay, let me guess, I'm going to have to do them all again. No, because my next smallest side is C. So yay, I'm going to get to what I want. So when I set this one up, corresponding side and angle, then I take my short side, and I'm going to find its angle, which is C, which is what I want. So see, I don't have to do 3 steps every time. Do my cross multiplying here. Let me get this out of the way. So I've got my 80 times the sine of 117. No, 117. Where did I come up with that? 81.7. That's better. And then I divide by 115. What's going with this side? So I'll just write that here, just so if I'm looking later, I know where the values are coming from. And I do my inverse on sine. 43.5 degrees, and I'm set. Okay. Now again, that'll let you do the last couple of problems from the homework assignment, the last one we got, where you had, I think it was 3 sides on 2 of them, to be able to see and finish that and do that. But we're going to directly turn around and apply that now to this law of sines applications. And again, when it says skip page 2, if you look at the back of this first page, it should look familiar to some of you, because it's the same worksheet that I gave you back in law of sines when I gave you the option between the book work or the worksheet. So if you want to give that a whack, you can feel free. So what I'm going to do is I'm going to pick a problem or two from each of these other pages and just walk you through how these work. A lot of them are going to have pictures for you. You're just going to have to put labels on numbers and then use the formulas. But I will warn you, it will switch back and forth some between sines and cosines. So like if we go down, let's say to number 4 here at the start, we go, okay, we've got Aaliyah taking a walk along a straight road. She decides to leave the road, so she walks on a path and makes an angle at 35 degrees with the road. So we're walking, here we go. After walking for 450 meters, she turns 75 degrees. Now some of you may say, why is it out here? Because when you make that turn, your body is making that turn clockwise, which is why it would be out here. So why would I have put 105 in here? How did I figure that out? Yeah, we minus it from 180 because it's a straight angle, and I want to know the angles that are in the triangle. So I wrote the 105 in. So I get going here, and it says how far does Aaliyah need to walk in her current path to get back to the road? Now again, I'm a fan, when you have your triangle, of labeling the pieces. So when you're doing this, you've got something that goes along with the formulas that you have. Now again, if you would change the letters around, you'd solve for a different letter, but the work would be the same. So how far does Aaliyah need to walk in her current path to get back to the road? In other words, we need to find side A. She was walking, she turned, she's coming this way to get back to the road. So I look and I say, okay, what information do I have that would allow me to do something? Do I have a corresponding side and angle? And at first I look and I'm like, I got the angle, I don't have the side. I got the angle, I don't have the side. Well, suck. I don't have the angle, I have the side. Well, that didn't work. Must be law of sines. So I start looking. Well, there's an angle, but I don't have the two sides. There's an angle, but no, I don't have this side. Well, shoot, screw this, I give up. No. Okay. When I get here, there is one bit of info I can get without doing laws of anything. What's angle C equal? 40. Because I know the other two angles, and I know they all add up to 180. So let me put that bit of information in and see if that changes how this is going to work. Ooh, it does. Because now I've got a corresponding angle and side. I'm going to be able to do law of sines on this. So I do the sine of 40 over 450. And then I look and I go, okay, and I'm looking for side A. And I have its angle, 35. And I'm going to figure out what side A is. Not looking for an angle, so there's going to be no second involved here. So I get here and I go, okay, I want the calculator to do the heavy lifting. I look and I go, here's my cross-multiplying part that doesn't have the A, so I multiply those together first. Get that set. Whatever's with sine A, we divide by that. So divide by the sine of 40. Which tells me that A is going to be 401.401.5 meters. One step, one cross multiply, we're done. So then I look at part B. When Aaliyah returns to the road, how far along the road is she from where she started? So she went up, she went over. Now, how far is she from here to here? In other words, how long is side B? You see, when I can make a connection, it's going to make it easier than just looking at it and kind of throwing my hands up. So I'm like, okay, well, I already know I can use law of sines. So the sine of 40 over 450, or I could do sine of 35 over this. I know the angle. Angle B is 105. I'm trying to find the side. So it sets up exactly the same way as part A did. I get there, I'm like, okay, my diagonal, it doesn't have the B. I multiply those together first. And I'm going to divide by whatever's with the B, which is sine of 40. And I'm set. So a lot of these aren't going to be lengthy, huge, but they are going to make you think a little bit about what do I have and what can I do with that. So again, the back of this page, whack it. We got some more apps coming here. So we're going to go down to number 4 on that next page. We're going to go to the island problem. So we've got island A is 220 miles from island B. Okay. A ship captain travels 320 miles from island A, then finds that he is off course. Okay, so 320 and 150 miles from island B. Okay. What angle in degrees must he turn through to head straight for island B? Now, I really am looking for this, but that's not going to help me when I'm going along here. I want this angle. So since those are A and B, I guess I'll call this C. So I want angle C. But unfortunately, which angle do I actually need to find first? Cosine, which side do we use? The biggest. So we're going to be finding B first. So you're like, okay, we're going to find B. So the cosine of B, and then I just use my formula that I've got. So we're going to take a squared plus c squared minus b squared over 2 times a times c. And I'm going to let the calculator, put my little -1 there to remind me it's an angle. I'm going to let the calculator do my cranking. Bless you. And now it's just basically comes to my competency to be able to type what I see, which shouldn't be too bad. And again, even though it's a negative, don't worry. We're just going to plug that in to my cosine, and even if you just typed in -0.477, that would work. That's a big old angle. But again, not quite what I'm looking for. Now we always just hope the next one is going to be the one that works for us, but we start looking and we're like, oh, A is the short, oops, doesn't help my calculator's in front of it. A is the short side. I gotta find A. Okay, but again, it's not going to take long because now I have a corresponding side and angle. I had somebody earlier ask, well, could I just do law of cosine again? Not really, because again, we're going to start getting into some possible issues with decimals and rounding and stuff, so I'd really prefer that you didn't. I have A, I'm going to find the sine of A, and then I'm going to be basically done doing mathematical calculations for this one, because I'll just be subtracting after this. So 150, get our sine going, divide by the 320. We're kind of getting into a groove now because we've done so much of this cross multiply and divide. It's becoming second nature. And we finally get to finish up, finally, because C is just 180 minus the other two. C ends up being 37.2. So again, don't flip out. One last one, because I just want to make sure. Especially on one that doesn't have a picture. I want to draw the picture. So let's go for 5 here. Okay. Marion is using a computer-aided drafting program to produce a drawing for a client. She begins a triangle by drawing a segment 4.2 inches long, all right, from point A to point B, all right. From B, she moves 42 degrees counterclockwise. Now, remember, counterclockwise means we're going opposite of what a clock does. So if I go and I start going counter, it tells me it's this angle. So 42 degrees. And draws a second segment that's 6.4 inches long, ending at point C. To the nearest tenth, how long is it from A to C? In other words, we're hoping to find B in a fairly short mannered fashion, but we'll see. So I look and I go, please let me just get one of these that ends quickly. So I start looking, I'm like, wait a minute, I don't have all 3 sides this time. Ooh, wait a minute, 2 sides and an angle that's trapped in the middle. Now this is that law of cosine stuff that we were doing on Friday. Ooh, and it means I'm gonna find that. Oh good, I get to be done the first time this time. About time. So I go back to my formulas from the front of my sheet and I go, okay, I'm gonna find b squared. So when I'm going through, again, I take the squares of my other sides. But this time it's not a fraction, remember, because I'm looking for the side, not the angle. So minus 2 times their product. Scooch over a little more here. Times the cosine of 42. And the nice thing, I can slap that whole thing in the calculator and then just take the square root at the end. I don't have to do a bunch of different pieces and worry about parentheses and all that other fun stuff. But I do have to remember this time to take the square root of this. So let me just kind of jot this down in case something goes haywire. Square root of that. And I'm set. So again, your job is to knock out the rest of these. You will have some work time tomorrow, but I'll say like I always do, if you don't reinforce it before your head hits the pillow tonight, you will not remember how to do any of this tomorrow. So I'm going to expect to see a triangle and something tried before we go into I don't get it mode. I mean, even now at 10 minutes, do like one problem. Not even like a bunch, just one. Just pick one in there. I've got the key up here. You can check it, see how it's going, and then get yourself into good shape. So hopefully you do.